So we're here to solve this Fillomino by Ashish Kumar. The very first thing I notice is probably cued off by the theme, which is the center square. The question you can ask yourself is what kinds of digits go in there? They can be no smaller than 1, but actually because the 1s are already surrounding each of these cages, they actually have to be somewhere between 2, 3, and 4. And let's say we had something like one of these 3s come in a cell. We're leaving behind 3 more cells, but 3s don't go in there, and now we need to put a 2, for instance, in this, but we leave them behind a cell that can't be a 1, a 2, or a 3. And so you can make a quick but tricky deduction that the center is a hidden shape, which is not going to be influenced by any of the numbers around it. It is a fully set 4. We've got these places already fully set. In a case like this, 3 can't come straight over to the cell because we'd isolate the clues above and around it. And I think that's going to be one of the steps we're going to work into as we think about this, is how if these start to come out, they're going to push the cells around it. But the other place that seems pretty prime at the start is this upper left corner. It looks like a prime place because it has a hidden polyomino that's adjacent to a 1, so it's not a 1. It's got to be larger than that, but it can't be too large because it's seeing a 2 cells away. It can't be 3 large because after taking 3 cells, it's now connecting with a 3, and it can't be 4 large because after 4 cells, it's there. So it's at least 5 in size, and what it does is forces some of these shapes right around it to start to fill in. So this 3 has to come down, but then goes across. That actually limits here, this 3 coming up. Looks like the 4 is forced to do this shape, so the 3 comes up. So this is exactly a 5, we now know. We've got a hidden polyomino coming out from here, which is at least 3 or more large. It actually has to, it looks like it has to be at least 4 large because it can't take a 3rd cell without touching one of these groups. And if it's at least 4 large, it takes this cell. So it comes to here. This 3 is pinned and has to come to the right and then has to come up. This 3 has to come to the right and then also has to come up. So this is a hidden 4. These 4s can't touch, but there's no form of this polyomino that doesn't take this cell. And then this 4 has to take at least this cell and this cell. That's now putting a fair number of constraints down on this big 9 region. And there's even some more we can probably say pretty quickly, really in terms of how like these 3s will eventually interact as well and take space. But let's come back to this lower left side where our completion of the 3 and 4 actually had pinned a set of these clues to come starting working out. The 3's got to come down. This 4 looks like it's got to come to the right. We now have 2 groups that are each using 4s, but we can't join them because the group would end up being too large, so they're going to dodge each other. And that dodge looks like this. Isolate another hidden polyomino that's 2 in size. And this is a hidden polyomino that's 2 in size. We've got this big group of 9, and we've got these groups over here. Note that none of these 3s are going to touch each other, so the question is really how do we fill in a space like this, and maybe this is a key cell. Like you could put a 1 down here, but what's the digit that goes in this cell? It can't be a 1, it can't be a 2, it's got to be 3 or more. So it's going to connect up like this. And if we had a situation where this 3 had to come down, it would force an edge here because you couldn't join a 3 into this group of 3 size. But still, this has to take at least 3 cells. And why is that? If it were a 1, it puts a 1 here. That's no good. If it were a 2, it's next to a 2. So it's at least a 3. This must take at least this cell. And now if it's a 3, it would literally take these 3 cells and put in this edge. And if it were a 4 larger, it would take this edge. That's trying to sort of show you 2 ways that this 3 can't come down. And so it actually comes up. And then because of the surrounding clues, is going to come to the right. That actually puts this 3 in quite quickly by dodging. It forces this 4 this way. The 9's got to take at least as many cells as it can. That's starting to crowd this 3, so these come in. This 9 is still taking cells. Notice that this now can't come all the way over to here, so this is a 3 or 4, and will be a separate group from the ones we've been contemplating. Can this 9 touch to this 9? Well, it also has already taken 7 cells, can't take all the way to this. So these are distinct 9 groups, and there are only 10 cells down here, but we've got to keep 1 cell away from where the 9s would be. So we can fit exactly this 9 in with a singleton there. And now this still needs to take 2 more cells, so I can take this one, can take this one, put in the 3s, finish out this 4, and 1 last hidden polyomino, and we finished. So a clever theme to get started with a center hidden polyomino shape in the upper left that really starts the flow, and then some thinking about a hidden polyomino in this corner, and really some constraints about, given that this cell in the 9th row far right has to at least join up to the group above it, that places a limitation on the cell that's kitty corner to it, that it can't come further down because it then isolates this group to have to be exactly size 3, but is touching another group of size 3 and would be too large if it were the same polyomino. So really clever logic. Hope you got through it, and if not, hope you learned something from this video, and we'll see you again soon.